Hello friends, welcome again to our session on overcurrent and earthfall protective relaying. In the preceding four sessions, we have already discussed about the concepts of overcurrent and earthfall protective relaying. We have discussed in detail about the coordination of non-directional and directional overcurrent protective relaying. We have discussed about the concepts of instantaneous, time delayed and IDMT relays, why different types of IDMT characteristics are required. We have also discussed about the setting guidelines and application examples for overcurrent protective relays. Uh, we have discussed the challenges associated with the parallel feeders, coordination during parallel feeders, coordination for the ringman system with multiple sources. So all these things we have already discussed. In this session, we will discuss how to determine the directionality of directional overcurrent protection relays. That is, in this session, we will discuss how to determine the operating range or operating area for a directional overcurrent relays. We will discuss about the concepts of polarizing quantities, the concepts of RCA, and the concepts of ROA. These things we will discuss in this session. So now, without wasting any time, let us start with our today's session. So all these things we have already discussed in our previous sessions. And now, from here, our today's session starts. This session, we will specifically focus on the concepts of RCA, ROA. The implementations in various numerical relays like ABB, Siemens, GE, uh, Alstom, NR, these we will discuss in separate sessions one by one. So today's session, we will only discuss about the basic concepts of RCA and the polarizing quantities. So now, what is polarizing quantities? In the previous 3-4 sessions, when we were discussing about directional relays, we were saying that the directional relay it should operate only in one particular direction of current. That means, suppose if the current is flowing from source to load, it should not operate. But when the current is flowing from the load towards source side, that means there is some fault, and in that conditions, the relay should operate. These things we have discussed in our preceding sections. But we also know that all the alternating quantities for a 50 hertz system, if we see, in every 10 millisecond, the current direction will change. So if in one block of 10 millisecond, if it is in one direction, in second 10 millisecond, it will be in the other direction. So that means now if we want to determine the direction of any alternating quantities, we have to determine that direction with respect to one common reference. So that common reference is called polarizing quantities. So the direction of alternating current may only be determined with reference to a common reference signal, and that common reference is called polarizing quantities. Uh, in power system relaying, the most convenient reference quantity is polarizing voltage, which is taken from the power system voltages. Now, is the meaning of this polarizing quantity? If you see, suppose we want to determine this direction of S2. S2 is any signal. Suppose this is current signal. So we cannot say whether S2 is positive or S2 is negative till we are seeing only S2. But if we determine the direction of S2 with respect to S1, now we can say that since S1 and S2 is in the same direction, that means S2 is the in the positive direction. So here S1 is a polarizing signal, and suppose S2 is also in the same direction, that means the direction of S2 is positive. But we also know that this it is not possible that all time the S2 is always in the same phase with respect to S1. So S2 can be lagging with S1 or can be leading with S1. But we know that till the time S2 is above this threshold, that is till the time S2 is in this area, it is positive. So that's why it is said that the direction of S2 is positive if it is plus or minus 90 degree with respect to S1 or 180 degree with respect to S1 in the positive side. So now this side is the your positive direction or the direction of operation. So if the S1 is in this direction and S2 is anywhere in this downside, it will be negative or restraint region. So now, how to determine this polarizing signal, how to determine the current that where the relay should operate, and which voltage is to select as a polarizing voltage. This is the main question. So the first thing, suppose we are discussing about the uh, A phase to ground fault or A phase fault. In that A phase fault, we know that the operating signal will be current. And now we have to determine this direction of this current with respect to a common reference voltage so that we can say that the relay should operate in that particular direction. That particular voltage, we have now the choice of 6 different voltage, that is VA, VB, VC, and then this phase to phase voltage. We also have the options of VA1, VB1, VC1, or VAB1, VBC1, VCA1. So this A1, B1, C1 is basically positive sequence voltage, and this positive sequence line to line voltages. So we have multiple options, and which voltage is to select as a polarizing signals, that is the important thing. Now, suppose we are selecting for A phase fault, we are taking reference voltage as VA. We know that for a transmission line, normally it is an inductive system. So if this is my voltage A, the current will always be lagging with some angle. Suppose this angle is phi. So now if this is always lagging, we know that if it is in the same direction, if it is at the same angle always, that means it is positive. And if this direction changes, suppose it becomes this, that means it is negative. This is one type of thing that we can say. So now suppose we are just simply we are saying that this is my voltage and I am also taking current in the same direction. And in case of fault, we know that the current will increase and the voltage is going to reduce. So now even if the current is increasing, it will always be in this positive direction, the upper semicircle. That means it will be the positive. It can determine the direction. But the problem is when the fault is very nearer to source or very nearer to the relay, at that time this voltage VAF is going to reduce. And when this voltage VAF is very small, it is very difficult to determine the direction. So if we are using VA for the A phase current, the polarizing voltage, if we are assuming the A phase voltage, then the chances is for a for a fault very closer to relaying point, the relay may determine the direction incorrectly. So then what are other options? The other options that we have is, now suppose we are using VBC. So we know that this is my A phase voltage and B phase for this phase sequence ABC. This is my VB and this is my VC. This VA is basically VA at an angle 0. This is at an angle 120-degree lagging, and this is again 120-degree from VB. It is lagging. So total from VA to 240. So now, if you want to determine VBC, VBC means what? VBC means VB minus VC. So first I have rotated this phasor, so it becomes VB minus VC, and then if you take the resultant, so this is my VBC somewhere here. So if you see now this VBC during fault, even if now VA reduces to any point, this VBC will always be here, and that VBC will always be fixed. So that is what here it is shown. This is the VA, and this is VBC, which is 90-degree with respect to VA. Why 90-degree? Because I have already shown here VA, VB, BC, and this was my VBC. So if you see, VBC is 90-degree with respect to VA. So if I am assuming VA here, VBC will be at this point. Now, at the time of fault, we don't know where my current will come. The current can be anywhere, like here, here, here. Current can come at any point. But till the time the current is in the same direction as that of this. So current is in the same direction as that of this. We can say that this is the operate direction. If the current is in the opposite direction, we can say this is the restraint direction. So this is the basic concept that is used. This VBC is now it is called the quadrature voltage. Why quadrature? Because in terms of the A phase, it is 90 degree. So it is quadrature. Similarly for for IB, it will be VCA, and that will be again 90 degree. So this is called quadrature voltage, and any current which is in this direction it will be positive, in this direction it will be negative. So now the next thing is relay connection angle. What is the meaning of relay connection angle? uh, Basically nowadays we are using numerical relays. Before, we were always using this electromechanical or static relays. In case of electromechanical or static relays, it was not possible to determine internally the VBC or VCA like this. So if we want to determine VBC, we have to connect the relay voltage in such a way that the relay should measure this quadrature voltage only. So now if we want to measure the quadrature voltage VBC, so we have to connect the to this A phase relay, the current of A phase and the voltage of B phase and voltage of C phase in such a fashion that the relay should measure VBC. And this type of connection in which the relay is measuring voltage VBC and current IA is called 90-degree connection. Similarly, in those days, we also have the connections for 30-degree, 60-degree like that. But generally, all the relays were because this 90-degree connection is very simple to make. So all the relays were having 90-degree connections. Now, what is the meaning of RCA or relay characteristic angle? Basically, this RCA it comes from the electronic relays or numerical relays or digital relay times. Earlier, we always know that what we have to do. We only have to give the current IA and the voltage VBC, and if the relay is at the time of fault, if the current is in this direction VBC plus minus 90 degree, then the relay will operate. Otherwise, relay will not operate. Now, in case of electronic relay, we also know it is again the same thing. This is my voltage applied, this A phase voltage, and this is quadrature voltage VBC. So, the RCA is the angle by which the current applied to the relay must be displaced from the voltage applied to the relay to produce maximum operational sensitivity. In case of electromechanical relay, if you see there we only have the connection angle and we are not changing anything. We are just applying the current IA. We are not applying IA at any angle. But now electronic or numerical relay we have the option. So if the current applied to the relay is displaced by any angle, suppose 30 degree, 40 degree, 45 degree, that angle is called the relay characteristic angle or RCA, and that is basically the maximum operating sensitivity. So from where this maximum operating sensitivity basically comes, because we know that this is only for a simple example, suppose this is VA. We know that for whenever there is a forward fault, the current will be lagging VA with some angle IA. But we don't know at what angle this IA will lag. It will lag by this angle, it can lag by this angle, or it can lag by this angle, depending upon how much the fault resistance is. But one thing that we are sure is that VA, the IA is always going to lag VA by some angle. So, in case we want our relay to have a maximum operating sensitivity, we can set one current angle, like suppose this angle, and we now say that if the fault current comes into this direction, the operating direction will be positive. If the fault current is so, this angle, this shift in angle is called relay characteristic angle. So now if you see this example, VBC is the quadrature voltage for A phase, and this angle, if it is shifted 45 degree for maximum operating sensitivity, then this 45 degree is called your RCA angle. Uh, Now here is a very important thing. This 45 degree, we can say it in two different ways. we can say that this 45-degree current shift is from VBC plus 45 degree, or we can also say that this is minus 45 degree from VA. So depending upon how we are seeing this, we can say that this RCA is the plus 45 degree, but with respect to your quadrature voltage. But if we are saying RCA as minus 45, that means it is also the same thing, but that minus 45 is with respect to the A phase voltage. So depending upon how the different manufacturers are treating their voltages, how they are calculating their reference voltage, they can say the different thing. Now, this is one example of 90-degree connections with minus 45-degree RCA. Now again see here minus 45-degree RCA. First of all, I have to determine the 90-degree connections. I am simply considering here VA, VB, VC, and we know that VBC will be your at 90 degree with respect to VA. And now minus 45. Minus 45, we can say this minus 45 means what? Again, at this point, we don't know what is minus 45. I can say this, or someone can say this. If for them, the reference minus 45 is from VBC, then it is minus 45. If I am assuming for minus 45 from this A phase voltage, then this is minus 45. So generally, whatever RCA angle we are going to say, that RCA angle is with reference to some reference voltage. And these things we will discuss when we are discussing about different relays, like in ABB relay, how they are setting this RCA, Siemens relay, NR, GE, Schneider, Micom, Alstom, every relay, we will discuss how this minus 45 or plus 45 they are treating. This thing is exactly same, but the way of saying it different with different manufacturer. Generally, for A phase relay, we will calculate A phase current, B phase relay, B phase current, C phase relay, C phase current. For A phase relay, the voltage, quadrature voltage will be BC. For B phase, CA. For C phase, AB. And now, if we are saying 45 degree, 45 degree with respect to your quadrature voltage, it will be in the uh, anti-clockwise direction, positive. If we are saying again 45 degree from VA, it should be in the anti-clockwise direction, negative. And I have already discussed that for this direction, this will be my positive operating directions, and that operating directions will be from here you have to draw plus minus 90 degrees. So plus 90 and minus 90. So in this way, now if I have drawn from here plus 90, so what is this angle? If you see from here to here it is 45. So from here to here again it is 45, because from here to here total angle is 90. This is 45, so this is 45. And we know that from here this angle is 90 degree. So if this angle is 90, this angle is already 45. So this angle with respect to it is 45. Likewise in this direction, this angle is 45, and we know that from here to here my this total angle is 90 degree. So this is 90 and this is 45. So with respect to A phase, this angle is 135. So we can say that the operate direction will be from 45 to 135, or we can say like this angle is with respect to A phase voltage, the angle of operation is plus 45 to minus 135 degree. Uh, Similarly, if we are saying this with respect to VBC, then the operating direction will be this angle is 45 and this angle will be 135 with respect to your VBC. So it is only a way of representation. We have to see which manufacturer is using which voltage as reference voltage. Now consider a case of 90-degree connection with 30-degree RCA. Again, 90-degree connection, 30-degree RCA means my connection angle is 90, that is I am using VBC as a reference polarizing voltage for A phase fault. 30-degree RCA, this is not minus 30, this is 30-degree RCA, 90-degree connection. So 30-degree RCA means now with respect to quadrature voltage, my applied current will be 30 degrees shifted. So now if we want to determine the operating direction with respect to A phase voltage. So this angle is 30 and I have to draw plus 90 and minus 90 from here. So this is 30. This angle I know it will be 60 because total is 90. So if this is 60 and from here to here is 90, so that means this will be 30 degree. And in this direction now this is 60 and this is 90, so total will be 150. So my operating direction will be plus 32 minus 150 degree if I am taking into consideration the A phase voltage. So with respect to A phase, if the fault comes and the uh, current direction is, or the current with respect to voltage is from plus 30 to minus 150 degree, the relay will treat it as a forward fault and relay will operate. So the selection of this RCA or relay characteristic angle, it depends upon many factors, but the three prominent factors are, first of all, the type of fault, that is whether it is a phase-to-phase fault, phase-to-ground fault or three-phase fault. The second thing is relay connection angle, whether it is 30-degree connection angle, 60-degree connection angle, 90-degree connection angle. And third type is the feeder types. That means the location of the strongest zero sequence source. So some of the selection criteria is uh, now this all these slides are based upon the paper from Soniman, so you can refer that paper. It is available on Google. So if my feeder is a simple plain feeder, but source of zero sequence is behind the relay. So this is my relay where the relays are installed, and now you see this is delta star transformer with star grounded. That means this zero sequence source is behind this relay. In that case, the general guideline is to select RCA 30-degree leading. If the source of zero sequence is in front of the relay, then should be 45 degree. For transformer feeder also it should be 45 degree. In this session, we have only discussed about some of the basic concepts of RCA, ROA, and polarizing voltage. Uh, we have discussed how to determine the 90-degree connection, 30-degree connection, 60-degree, 45-degree RCA, etc. Uh, the polarizing voltage, I have already told you that the polarizing voltage could be the quadrature voltage, could be the same phase voltage, it could be the positive sequence voltage, positive sequence line to line voltage, and different manufacturer uses different type of voltages that we will see from our next session onwards when we are going to discuss about the particular relays of a particular vendor. I hope the concept discussed in this session is clear. Only thing that you have to remember is RCA is only the current which is the how much degree the current is displaced from your applied voltage. Now if I am considering the quadrature connection and the applied voltage is 45-degree leading from the quadrature voltage, then the same thing can also be said that it is lagging 45-degree with the same phase voltage. Uh, we will keep this session only up to this point. We will meet again in our next session with the discussion on relay specific settings. Till then, thank you and goodbye.